Thank you everyone for coming. This session will be about machine learning versus agentic AI prediction. And I want to say thank you for Rona and Guy, the Israeli team from Databricks, that making that a reality. So thank you.
Okay, in 2023, a client at JLL found that they had been paying the wrong rent for 8 years. Not wrong by a small amount, wrong by enough to matter over that 8-year period. The data had been checked manually, it had been signed off, it had been signed off every year, and still the lease data was wrong. Everyone did their job, it was still wrong. The client was out of pocket, we were in the doghouse, and so that story is the one we want to tell today. My name is Andrew Ray. I support transformation across JLL's businesses, and this is Jonathan Bauman, who is the head of technology and R&D at Dealsum. We're going to spend the next 40 minutes showing you how we fixed that problem, and we're going to show you why it is not fixed in the way that you might expect. So what changed? Here are the numbers. The smaller numbers are our old machine learning numbers. The new ones are with our new Agentic AI supervisor solution. Accuracy is up between 92 and 98%. 98% is for some of our leases, 92% is the average across the entire production estate. Across all production volume, that average is 92. That compares to 65% in the old machine learning world. Review time per lease is down from 130 minutes to 85, 70% versus manual. AI processing time is down from 30 minutes to 5. We will spend the rest of the session explaining how and why our approach is not what the rest of the industry is doing. Cost. I want to address a commonly held assumption that machine learning is commonly perceived to be cheaper than using agentic AI. So that's true per operation, but we're not measuring operation, we're measuring abstracted, accurate leases. On that measure, cost is down 30%, versus our old pipeline, and 70% versus manual. Compute goes up, sure, but review time drops, net cost drops, and that's the measure that we really care about.
Okay, so let's talk quickly about safety and compliance. So the way we build that pipeline is basically the same thing as going to the doctor's office and having a needle in your arm. That needle will not go back into your arm or anyone else for that sake. It will be just throwing into the bin. And this is essentially what we did. It's like one model that uses once per session, per tenant, not even twice on the same tenant itself. So no training data, no logs, no nothing. The second we finish that prediction layer, we just delete it, and that's all for now. And also, this is something we did many times so far, because it allowed us to change the model. If we find a new one or better one, cheaper one, we just can replace it with zero cost and zero complexity.
So from JLL's perspective, that point about data security is hugely important. Our clients' lease data is commercially sensitive. It's not a nice to have, We cannot have our data being trained on AI models. In many cases, it's a contractual restriction. So Jonathan's architecture delivers that by design, not just by policy. And that is what gets us through the reviews with our clients' legal and compliance and security teams. So quick context on JLL. Not a history lesson, but the scale is important to the problem we're trying to solve. We work in over 80 countries, 113,000 people, and we have 5 billion square feet of managed real estate. Every square foot sits inside a lease. Every lease has to be read, abstracted, and managed accurately every day at scale. That is our reality. So if we think about complexity, that's just the starting point. JLL adds another layer. We work across 175 legal jurisdictions, each with their own rules, formats, names. We have 45 languages. Every client has their own schema, their own field names, their own requirements. A lease for a technology company in Singapore looks completely different from a retailer in Germany or a logistics company in Brazil. There is no universal template. There is no shortcut. The margin for error is zero. So, commercial leases. 2,500 data points is what we typically abstract from a lease. That's not unusual. It's fairly typical. In commercial real estate, the 1% that is wrong is usually the field that matters most. A wrong break date, a missed rent escalation, a calculation error buried in an amendment. I mentioned earlier a client who paid the wrong rent for 8 years. Everyone had done their job, the lease was still wrong. Getting accuracy right at this level of complexity is genuinely difficult. Almost correct is still incorrect. This is not a quality standard, it's a legal and financial reality.
So let's talk quickly about DILSAM. We are in the business for about 12 years now, and we started with machine learning when it was the modern way to do things. And at the end, we provide 100% accurate lease data, meaning that we read lots of documents and long legal documents. We provide an abstraction for those documents, and for that particular tenant, we read all of the documents that are existed under his folder, and a human verifies the data because we can provide 100% without a human in the loop. So we will always have a human in the loop that verifies the data correctly. So essentially, DILSAM is a lease data library that at the end holds golden data set of real estate, commercial real estate leases.
So leases have been around for a long time. We started off doing them before software with paralegals that would take a week. We then did spreadsheets, we then did applications, and then finally we did machine learning, as Jonathan alluded to. Each time, we've hit the ceiling. We've improved the timing and reduced that time, but we've always hit the ceiling, the hard parts, reasoning through amendments, cross-referencing definitions, resolving conflicts. All of those still need an expert human. Jonathan will explain why this time it's genuinely different.
Yeah. So let's for a minute compare two things. We know that in demos, AI look very impressive. So in demo leases, when you build an AI pipeline, usually it looks like this. Demo lease with straightforward sections that are showing exactly the clauses that you need to extract with everything in one place. The rent is explained very well. The renewal options are very straightforward. The permitted use is genuinely written explicitly. But in production, you may have documents that are with 30 plus amendments, and you have amendments that overrides each other. And sometimes you will have dates that derived from another date, or a number that is being derived from another number. And also you will have a very large amount of variations of leases. So this is the example of one PDF that is super straightforward compared to 30 PDFs that is messy and basically all over the place.
So a commercial lease is a contract. A tenant gets the right to use space for a fixed period in exchange for rent, with obligations on both sides. That's a super simple way to define it. Very difficult to interpret when that space is over multiple jurisdictions, multiple languages, and the amendments go back years and years and years. So a lease will basically break down into three categories. Money, not just rent, but escalations, abatements, common area maintenance charges and operating costs. Time, not just the term of the lease, but also renewal options, break rights, notice windows. Miss a notice window and you can lose a right worth millions. Rights, they are what the tenant can and cannot do with the space. So the challenge here is that these three categories interconnect. A common area maintenance calculation depends on the rent base, which depends on the escalation history, which runs across amendments spanning potentially decades. Each link is a place where simple pattern matching fails. What's needed is real reasoning.
Let's give that into a real-life example. We earlier saw the left side of the slideshow, which is the demo lease, that it's kind of straightforward. And then on production, you will have a 1993 lease with 29 amendments that was scanned in 2008. And you will have multiple long documents of that lease, amendments that overrides another amendment, and clauses that are referencing another clauses for that particular lease. And this is the example of a lease that we actually deal with in production. So let's give it like a bit of a timeline for that specific lease. So we are seeing like an office lease that was signed in 1993 and is valid until 2029. We have 29 amendments over 32 years, and a lot has been changed during that time. So essentially, a floor was added as a temporary, a floor was removed, and each of those amendments changed the square footage and the rent. So if, for example, if we want to ask the AI, what is the current square feet or how much rent we need to pay, we can have dozens of answers. Each one of those is correct because it has citations to the original document and should be a valid answer. But in reality, we want to get the latest document and the latest version, and it's not so easy and straightforward.
So the cost of 1%. A retail lease, 10 amendments. The construction allowance starts at 453K. The first amendment raises it to 667. Second raises it again to 683K. If the system misses the amendment chain and delivers the original number, the tenant is short $230,000. That is one field on one lease, and JLL processes thousands of leases with thousands of data points. the exposure compounds really quickly and it's silent. You don't see it until you're 8 years in. This is why we say that almost correct is still incorrect. It's not a quality goal, it's legal and financial statement.
So let's talk about accuracy real quick. So accuracy is a well-known issue. Imagine doctor or lawyer or financial analyst getting recommendation by AI, but just ignore that because they don't trust the answer. It simply gives the answer, but doesn't give enough evidence to support that answer. So what we built here is basically a change. Instead of understanding which citation we want to do, or the human in the loop need to understand which answer is right with machine learning, with agentic AI, it just needs to pick the right answer and to verify that the citation and the evidence that was provided is good enough for, in terms of confidence, in order to select that answer. And this is exactly where machine learning fails. So sometimes in lease documents, you will have implicit answers. For example, commencement date will be 30 days after something that happened. And machine learning understands the formula, but doesn't understand which date you need to put in that contract. Same goes for rent escalates. If the rent escalates per year by greater of 3%, but you don't know the CPI of last year, essentially you know the formula, but you don't know the number. And the same goes for conflicting answers. As for the example we showed before, if you have two amendments saying two different numbers, at the end you need to pick one. One of them should be right and the other should be not. And if you will give that document or problem to general model AI as of today, you will just can hallucinate one answer, which will be right because you have citations and you have reference to the original document, and it seems true. But in reality, it's not, because you need to count for all of the amendments date by date by date until the latest one, and by then find the right answer. Another issue that we have is partial data. Sometimes data is not explicitly written in one paragraph, so you can use traditional RAG and embedding to find the right answer, but you need to combine it from multiple sources, even with the same lease agreement. And the last is ambiguous clauses. Sometimes machine learning can think or can decide that he has a specific answer, which is right, wrong, we don't know. But agentic AI and the capability of the reasoning in the AI can provide us an ability to really understand if the clause is supposed to be true or not true, if we got the right data or not. So let's dive quickly into Databricks tools that we used in order to solve that issue. So first of all, we have the AI search, which is the retrieval system that gets the data from the documents. And then we have the Unity catalog plus Delta Share, which makes the integration with JLL and downstream system so smooth. An supervisor agent will control and orchestrate a bunch of agents that will do that task that we will explain later on. Genie will give the end user the ability to ask any question that he wants on thousands of leases and get the right answers back, because after the human reviewer confirmed that we have 100% accurate lease data, then Genie becomes much more powerful. LLM Judge is the tool that makes the agents appear reasonable and provide real evidence. And model serving is the same thing that we explained before, about safety is the basic mechanism that allowed us to use AI, one-time use, and then dispose that AI model. We are essentially deleting the AI endpoint when we are finishing using it.
So from JLL's perspective, that Unity catalog matters most. We're a global operation with the strict data requirements. One governed data layer shared by both JLL and DealSum is what makes this an enterprise-ready platform.
So let's dive into the high-level steps that we are doing inside that pipeline. So first of all, it's pre-processing, preparing the documents for the AI to engage and act. And then the latest one is the post-processing and delivery, which will be streamed into Genie and downstream system, BI, and so on. So we will start with pre-processing, which is the document index. We gather all of the documents of that tenant and structure them in one specific index. And search index build will allow us later on to find any specific data that we want to inside that tenant document list. And then on top of that, we built sophisticated RAG on top of Databricks AI search capability. So we know that leases are being built with a structure that contains table of content. So each section and each clause in that lease has a specific reference, a specific section that is being assigned to. And we took all of those data points and we gather them in a document graph that holds all of the documents combined. Because if we want to ask something about rent, for example, we want to make sure that we have the rent information from all of the documents that has been uploaded into this specific tenant. So if we will miss one of them, what will happen is that we will get an answer, but not the correct one, essentially. And it might be leading to silent failure, because if you haven't read all of the amendments of that lease, essentially you can be sure that the data that you are providing to the human reviewer is actually true. So let's understand real quick the LLM structure that we built, which is, I know, a bit of let's say, usually what we do is we take the biggest AI model that is available. We are taking all of the documents, putting them inside, getting all of the list of questions that we want to get an answer of, and putting that inside as well. And essentially praying really hard that the model will not hallucinate and we will not get answers that looks very much right, but essentially they are not. So what we did is we took that complicated problem of lease abstraction and long document of lease data, and we slice it into a salami version. So essentially, instead of solving like a big problem, we solved a lot of very, very, very small problems. So cutting it into very thin layers. So the AI will be able to do those assumptions almost without getting it wrong. And let's give an example for that. Let's say you have an equation, a simple equation that any 10 years old kid can solve. And you want to solve it quickly, not accurately, just quickly. Who will trust that will make it faster? Einstein or 18 years old kid? Essentially, the 18 years old kid will solve it faster. Why? Because he doesn't have the capacity to hallucinate. So Einstein will take that idea and start theorizing many things and dive into many theories, but at the end, the kid did that in 2 seconds, and Einstein just kept thinking. So this is essentially what we did. We sliced everything into very thin problems, equations that we can solve very quickly and efficiently, and we can reduce the hallucinations to almost nothing. And the supervisor agent is only the orchestrator of the pipeline. So we have 4 different agents. Each one of those is specialized with one task and one task only. One of them is doing the first pass extraction. It doesn't have any reasoning, any thinking. It doesn't need to cite anything from the contract. It doesn't need to understand nothing. You just need to take that question and get the answer you think is right. And then comes the quality judge. Quality judge look at the answer and understand whether this answer is right and have sufficient evidence or not. If he thinks that this is maybe not the right answer to this question, he will just pass it into the second pass correction. That will take that and work with a bit of reasoning to understand whether this one is the right answer or not. And the last one is the evidence augmentation, which enriches the answer. If we think that this answer is the correct one, it will find out the best possible citation in the contract to make sure that the human in the loop receives as much context as he can in order to understand that this is the right answer. So the agent has 4 things to think of, or more, the pipeline has 4 things to think of. One is, did we find the right answer for that question? Did we interpret it, the least, correctly, and we understood that this question is actually answering the problem that the question that we want to answer? And then, did that answer is actually fit into the client schema and data? And last of all, did we prove sufficiently enough that the answer is genuinely okay and can answer the question that we want to answer?
And that prove it step, that's the one that changes what the reviewer does. Before, the reviewer is investigating, having to dig into all of that detail. Now, they're just confirming that it's the right answer. That's a very different job.
So, yeah, what we wanted to do, and what we managed to do, is to make sure that the human in the loop has enough evidence that supports his decision, whether the data that we abstracted and extracted is actually true or not. So, as I explained, the AI reasoning has these 4 steps: extraction, judge, correction, and evidence at the end. Each part of those is independent to each other, so the extraction comes first, and then the judge flags whatever we need to change or rethink about the answer, and then the evidence comes last and make sure that we have sufficient evidence. And last is evaluation, because in our use case, evaluation is a bit different. Usually AI, you ask something, you get an answer back, and there is like basically 2 answers, whether he got it right or wrong. Here, it's a bit different. We need to evaluate whether the answer that he provided back is sufficient enough to support the claim that we wanted to. So we need to also check whether the answer is good, and also whether the proof that he provided is sufficient enough. So we started building the evaluation layer second, and if I would do that today, the entire pipeline, I think I will do the evaluation first. And the last thing is post-processing and delivery. So final quality check when the pipeline is finishes, and then data standardization, which means we format the field into dates, drop-downs, addresses, so on and so on. And then we compile all of the answers and provide them to the human reviewer to make sure that he can do his decision efficiently and quickly enough. And the last thing is result storage. So when we finish and we have 100% accurate data, so we push it backwards into Databricks and downstream system and Genie, as we will show in a second. So this is our implementation of Genie chatbot, and we think it's the most interesting thing we built so far because it has the ability to query dozens of leases in one go. Andy.
So we're asking it which tenants will expire in the next 90 days. It's going through the entire data set, all of the abstracted data and the documents, and it's coming up with the answers. We're going to then ask it what the new base rent is for those so that we can figure out what the cost impact is of those lease changes. And you'll see that it's coming up with the answers. And what that does is allows a portfolio manager, for example, to rock up in the office at 9 a.m., ask those questions, and get instant responses back. Now, that was impossible up until today. And the answers are verified, validated. We know they're correct.
So integration is a big piece of that. And as it comes to moving the data between SaaS platforms, as we are, and enterprise data storage, we automated that part as well. We worked closely with JLL to close the gap and make sure that the data is being added automatically into all of the ERPs. This is not just like one downstream system. They have more than 20 downstream systems, and every system need to hold the data, the real data, with confidence. So no manual entry whatsoever. Yeah. So let's go over very quickly of what we had so far. We had a specific architecture that is not so trivial, let's say, that build maybe a little bit different, that uses AI a little bit different, with a separate agent, endpoint, and document graph, and so on and so on. So this came from a specific requirements or a specific roadmap that we had with JLL for a long time. And it came from trial and error. So we didn't knew that we are going that way all along. We just followed the common sense and ended up with the pipeline that we just shared with you.
So we started this session with 3 sets of numbers. 92 to 98% accuracy, reviewer time cut by 35%, and costs down by 30% versus machine learning. Those numbers came from one decision, and that decision was to really understand the problem before we delved into the technology. The pattern behind them, the specialist agents rather than one powerful model, the evaluation built in from the start, the governance as a design principle, not a bolt-on extra. None of that's unique to lease data. It works wherever the risk is high of an overconfident AI bot giving a well-cited incorrect answer. So if you're facing that problem, do please come and see us afterwards. What the partnership has taught me is that most importantly, the investment was not in the technology, but in understanding the problem. Einstein said it best: if you have an hour to solve a problem, he'd rather spend 55 minutes understanding that problem and 5 minutes finding the solution. We didn't move fast, we moved deliberately and carefully, and the results now speak for themselves. Thank you.
Yeah.